All right, welcome back. We are continuing with the notes for 5.9 where we're looking at displacement and total distance, and I now have a calculator installed on this computer so I can show you guys how to input that. Let's take a look at a couple examples. Number 3, and this is actually super common. You might notice that they give you the velocity. That's probably the most common thing for you to be given, and here's the equation for the velocity. T is time. For our input, we want to write a position for the function. We want to write a function for the position. Let's get that right. Well, I want to then undo the derivative that is on velocity. Let's just let the position equal s of t. That's actually a common notation for position. Now, if you are ever going to introduce a new variable like that, you do need to tell the reader, hey, I'm calling position s of t. So s of t could be found by integrating v of t. Now, this is going to have a constant in it because I'm doing an indefinite integral. So I want to integrate this 4t to the third minus 3t squared with respect to t as my input variable. So s of t, if I use the power rule, would be t to the fourth minus t to the third plus c. Now, we don't know what c is. They'd have to give us some more information in order to find out what that would be. If we want to find the displacement of the particle on a closed interval, what we would want to do is we would, using this formula up here for displacement, we do not want the absolute value for displacement. Displacement, remember, is just the change in position, the change in the starting and ending position. So we want to keep the signs in this problem. We want the times that we kind of cover the same ground twice to cancel out, like if one is in a positive direction, one's in a negative. So we definitely don't want the absolute value here, but the notation here is important. I would like to take the integral from 0 to 5 of v of t dt. Now, if a problem is calculator active, which I'm going to make it calculator active, that's literally all that you actually have to type or write on your paper. And then certainly we could integrate this by hand. We actually already know that the integral would be t to the fourth minus t to the third evaluated at 5 and 0. So there's nothing wrong with doing that by hand, but just as a nice review for us, we can also do that on our calculator. So I want to do the integral. Oh wait, actually, you know what I'm going to do? Let me go back. What I'm going to do is I'm going to define v really quickly because I know I'm looking ahead here that we are also going to find total distance. And so I'm actually going to use v twice. I don't really want to type it twice. So I'm going to go ahead. Let me just see if I can. Remember, you're going to type Control Enter to get the double colon here. And so v of t, now this is before I've integrated, is 4t to the third power minus 3t squared. And I'm just going to hit enter here. And we need to get the done. That's how you know. Now I'm going to hit shift plus. I don't know why my screen, I chose the wrong size for my screen. I apologize. But I hit shift plus here. And I'm going to do from 0 to 5 of v of t dt. I don't have to type it again because I've already told the calculator what v of t is. And I get exactly 500. And if I did this by hand, I would also get 500. But on an AP exam, you only have to write down this if it's calculator active. Now, if it's not calculator active, you would need to show your computation. This next question is very similar, but I want to find the total distance. The difference between total distance and displacement is that I don't want, when I travel ground twice, okay, like maybe going once to the right and once to the left, that velocity would once be positive and once be negative. And I don't want those to cancel out. I want to count it both times. So I want to use an absolute value here. And so I'm going to use the calculator here to do this as well. And let's see, let me switch this over. So if I would like to do the absolute value, let's see if I can shrink up the size of my screen here a little bit and move this so that you guys can see what I want you to see. Okay, so I'm going to still do an integral, so shift plus from 0 to 5. And if you want to do absolute value, if you go to the menu that's to the right of 9, you're going to see an option for absolute value that you can just pick. And then again, I'm just going to type v of t. because I've already got it stored dt. Now I will warn you that sometimes it can take the calculator a little while to calculate absolute value. This one was fine, but you will see there are times where you're just like sitting there waiting. And if you're on an AP exam and that's happening, you're going to just maybe want to like move on to another problem for a minute and then kind of check back in rather than sitting and waiting. You really won't have time to spare. Notice that total distance is a little bit bigger. And something that is true that you can count on, and actually I'm going to just really quickly check my settings since this is a brand new calculator. If you ever want to check your settings, this is how you can do it. You can go to the home screen, to the home page, and oops, that's not where I wanted to go. I wanted to go here. And go to 5 for settings. Check your document setup. See how this is float 6? I actually don't prefer float. I really prefer fixed. I would like to always see the extra decimals personally. So now if I go back to see what I'd been calculating in, oops, let me go back to my document that I was working on. If I can figure that out, well, darn it. I don't even know. Darn it. Okay, well, I may have gotten more decimal places on that one, so I'm really annoyed right now. Let's see. Do we want to save it? Yes. I don't even know. Sure, we'll save that. Let me go back then to that document that I was in before, maybe. See if I can get it. Okay, so I don't know how to use my calculator clearly, which is awesome. But if you change that to fixed 5, you'll get the extra decimal places. I think this one did terminate, so I think we're okay. But what I do want you guys to make sure and notice, and this is helpful, is that total distance will always be greater than or equal to displacement. And so if you ever get confused, if you're ever like doing a test and you're doing both of these and you can't remember which one has the absolute value, if you can remember that total distance will always be the one that is greater. Now there are times where they're equal because maybe there were no times that you backtracked and went over the same distance twice, but displacement will be the one that's smaller if there is one that's smaller. All right, part D. If the particle is initially at x equals 3 on the line, that might seem weird to you, but this is moving along a line. It's probably moving along like the x-axis here. Find the position when t is equal to 2. Well, I'm going to go back to what we did in part A. We had an expression for the position, which was the position was t to the 4th minus t cubed plus c. And this right here is going to give me an ordered pair. That term initially means that time is 0. So S of 0 is equal to 3. I can use this to find out what C is. And so I can plug in a 3 here. And time is 0, which will 0 out. And so C is 3. So I could think of S of t as equal to t to the 4th minus t to the 3rd plus 3. If I now want to find the position when t is 2, I could then substitute in a 2 into the problem and evaluate that. I'll get 16 minus 8 plus 3 is 11. Now there is one other way to do this that I think is actually kind of cool. Let's see what you guys think about it. Another way to do this is to recognize that if I want the position at some time, like B, and I know a starting position, which I'll call S of A, what I can do is say, well, then how much did it move? If I know the starting position, I want to add on to that how much it moved from the start to the end, which would be the displacement. So the integral, this is not 0 to 5, from A to B of v of t dt. So if I wanted to find the position at time 2, and I know the position at time 0, remember 0 is our input, then what I can do is I can take the integral from the starting time of 0 to the ending time of 2 of the velocity, which was given to us as 4t cubed minus 3t squared dt. And what we'll find out is that when you then integrate and evaluate at 0 and 2, you will get, let's see, 2 to the 4th is 16, minus 2 to the 3rd is 8, and then minus 0 from that, and lo and behold, you still get the 11. Now, I don't know which way you like better, but I will tell you that this model right here is going to become very useful as time goes on. So I don't mind if you want to start thinking about that and using that. This is a great model. If you know where you're starting and you know how far you've traveled, which is our displacement, you can find out where you are landing, which is pretty cool. All right, example 4. A ball is thrown up into the air and with an initial velocity of 50 feet per second. Keep in mind, initial means time is 0. Let's use v of t for velocity. So what they've told me, and let's use h of t for height, because they're mentioning both velocity and height. They are telling me my initial velocity at time 0 is 50, and the initial height, h of 0, is 29. We want to find the position function if we know, giving the height s. I guess we're using s for height, not h. We'll follow theirs. As a function of time t. So what we want to do here is we want to write the equation for the position function. You might feel like you don't have enough to start off with. You kind of have to memorize this next part, okay? What I need you to memorize is that the only thing that's working on this ball after it's thrown is gravity. Gravity can also be thought of as acceleration. And gravity as an acceleration is equal to negative 32 feet per second squared. So something that's implied in this problem that I'm now telling you that you're going to want to memorize is that if it's a problem where you're just dealing with something that's a free fall, and that's what's happening here, okay? You throw it up and then it's just the only thing working on is gravity, is that you can start off with the fact that acceleration is equal to negative 32. I'll use a of t for acceleration. Well, that's helpful because if I want to talk about the velocity, I can integrate the acceleration. So the velocity function can be found as negative 32t plus constant c. I do have an ordered pair for velocity where the output is 50 when the input is 0. And so this will allow me to see that that constant here is 50. So I could rewrite the velocity more precisely as v of t is equal to negative 32t plus 50. That's awesome. That's not quite what I want to find. I want to find position, but finding position, I do need velocity first before I can find the position. So now if I want to find the position, which we're calling s, I want to integrate the velocity with respect to time. So the position function could be rewritten as, if I use the power rule, negative 16t squared plus 50t plus c. Some of you students who've had physics are going, wait, I recognize this. And remember, we do have an ordered pair for position. At time 0, the position is equal to 29. So if I put in 29 as the output and 0 as the input, we can find out that the constant here is 29. So s of t could be written as negative 16t squared plus 50t plus 29. And you might even recognize this formula because when you were in Algebra 2, and I believe you also may have encountered this in pre-calc, you may have seen this. H of t is equal to negative 16t squared plus v sub 0, or v, the initial velocity of t, plus, or times t, pardon me, plus the initial height. Well, if you look at our original problem, our initial height and our initial velocity were given. Initial velocity is 50, initial height is 29. So now we've done the calculus, we've done the derivation of this formula, and you can see where it all came from. It came from the fact that when we're talking about measuring things in feet, the acceleration is negative 32 feet per second squared. And then we can derive all of our velocity and position functions from that. Now, you might wonder, if I see a problem like this, could I just jump straight to the answer? And the answer to that is no. We are going to require, I'll just tell you now, straight up, on your test, you are going to see a problem like this. You're going to be asked to prove the calculus. So you might know, hey, I know what my ending equation is going to be, but you still have to show the calculus to get through that. Okay, we will continue this video or the rest of these notes on the next video.